R and H are both variable. Radius and height of the cylinder both are variables here. Therefore, it is given here that the volume of the cylinder is 100 centimeter cube. Therefore, volume of the cylinder is pi r square h, which must be equal to 100 centimeter cube. This is your equation number 1. Okay. Now we have that has minimum surface area. Now minimum surface area means you have to minimize the surface area with the help of this relation 1. Okay. So write down the expression for total surface area. Total surface area of the cylinder S. If you remember, the formula for total surface area was 2 pi r into r plus h, right? So now if you see, we have to minimize S, right? But S has two variables, r and h. So we bring it down to one variable with the help of 1. So from 1, you can write h is equal to 100 by pi r square. Just give me a minute. Okay, so this is okay. So S has two variables, as I was saying. We bring it down to one variable with the help of 1. So from 1, h is equal to 100 by pi r square. Putting this value in, let's call this 2 above, we get S is equal to 2 pi r into r plus 100 by pi r square. Now you multiply throughout. It's equal to 2 pi r square plus 200 by r. Okay. This is the expression for S. Now it contains only a single variable r. So we find out ds dr. ds dr is equal to, you have 2 pi, differentiate r square, you get 2r. 200 you take out of the differentiation, differentiate 1 by r, you get minus 1 by r square. So what you are getting here is 4 pi r minus 200 by r square, right? So for maximum or minimum S, we have ds dr is equal to 0. That means 4 pi r minus 200 by r square is equal to 0. You can take 4 common to get 4 times pi r minus 50 by r square equal to 0. That means pi r minus 50 by r square is equal to 0. That means pi r is equal to 50 by r cube. R square, sorry. So now if you cross multiply, you get pi r cube is equal to 50. That means you get r cube is equal to 50 by pi. That means you get R is equal to 50 by pi to the power of 1 by 3, or you can also say cube root of 50 by pi. Now at 50 by pi, you can have either a maximum surface area or a minimum surface area. Now let me check the second derivative for maximum or minimum. Therefore, d2s dr2 is equal to, differentiate this here, 4 pi r minus 200 by r square. You get 4 pi minus 200, and 1 by r square, if you differentiate, same as differentiating r to the power of minus 2, you get minus 2 r to the power of minus 3. So you get here 4 pi plus 400 by r cube. This is the second derivative. Okay. Now we want to check at that value the sign of this derivative. At what value? At r is equal to 50 by pi to the power of 1 by 3 d2s dr2 is equal to 4 pi plus 400 divided by 50 by pi to the power of 1/3 whole cube. So you don't need to see that anything. Now you know that this is positive. Thus, S has a point of local minima. That means the surface area is minimized at r is equal to 50 by pi to the power of 1 by 3. Okay. And now we'll see what is the question here. The question here is find the radius of the right. Yes, we have found out the radius. Hence, radius of the right circular cylinder when surface area is minimum is equal to 50 by pi to the power of 1 by 3. Okay, any question?
No, sir.
We'll do the next question then. Fourteen. The question here is find the radius of the closed circular. Okay, 14 we have finished. I think 15 we'll do. Okay, 15 here is show that the a closed right circular cylinder of given total surface area. So total surface area is given. Okay, so total surface area is constant. S is constant, and maximum
Yes.
volume is such that its height is equal to the diameter of the base. Okay. Now, this is actually, if you see, this is just the converse of the last problem. In the last problem, the volume was given to you. If in the last problem, volume was given to you as 100, that means volume was constant, and you are minimizing the surface area. Out here, it's just the converse case. That is the minimum that surface area is given to you, and you will have to minimize the volume. Okay, so this is exactly the same as the last problem, except that it is the converse. The actual figure is not given. That is here the volume was given to be 100 centimeter cube. Here total surface area is not given to you. You can take it to be S, which is a constant. Okay, so again we draw this, and this is your radius, this is your height. Again we start by saying let R and H be the radius of the base and height of the right circular cylinder. Okay, fine. So now the surface area of the cylinder is given to you. Okay, so given total surface area. Okay, so therefore S, total surface area, S is equal to, formula for total surface area is 2 pi r into r plus h. Now before this, let me just write here r and h are both variables. Okay, and here S is a constant because it is given. So total surface area is given to you. S is a constant. Okay. So once we are aware that S is a constant and R, H and H are variables, now we are going to write down the function that we need to minimize or maximize. Here in this case, we have maximum volume, so we need to maximize the function that we are going to find out. Volume of the cylinder. Let us call this 1. S is equal to 2 pi r into R plus H. Let us call this 1. Volume of the cylinder.
Pi r square h.
Pi r square h. And now from 1, now pi r square h contains 2 variables here. So therefore we bring it down to a single variable. How do we bring it down? Let us call this 2. With the help of 1, we shall bring it down to a single variable. So from 1, you have S is equal to 2 pi r square plus 2 pi r h. Right. So therefore, you can find out the value of h from here. So S minus 2 pi r square is equal to 2 pi r h. That means h is equal to S minus 2 pi r square divided by 2 pi r. So you can also write this as h is equal to S divided by 2 pi r minus r. Okay. Putting this value into
Volume 1.
above, we get
2.
V is equal to pi r square, and h we have found out as S by 2 pi r
Minus r.
minus r. Okay, so now you can find out V as, if you multiply pi r square throughout, you get this as SR by 2 minus pi r cube. Now we need to minimize V. We need to minimize or maximize, let's see. Maximize. We need to maximize V.
Then we need to show it negative.
Therefore, dV dr. You first find out dV dr. dV dr you get as S by 2 minus pi into 3r square. Okay. This is your dV dr, which is equal to S by 2 minus 3 pi r square. This is your dV dr. Okay. For maximum or minimum V, we have dV dr is equal to 0. S by 2 minus 3 pi r square is equal to 0. That means S by 2 is equal to 3 pi r square. That means you get, in fact, R is equal to, you find out the value of R, S by 6 pi. R square is equal to S by 6 pi, right? That means you get R is equal to S by 6 pi to the power of half, or you can also write as square root of S by 6 pi. Okay. Now we need to find out, check the second derivative. D2V dr2 is equal to ddr of dvdr is equal to ddr of, and what is dvdr? We have found above, S by 2 minus 3 pi r square. Now if you differentiate S by 2, S is a constant, so it will be 0, minus 3 pi, and r square if you differentiate you get 2r, which is equal to minus 6 pi r. Okay, so d2v dx dr2 is minus 6 pi r. Now we just need to check the sign at r is equal to S by 6 pi to the power of half d2v dr2 is equal to minus 6 pi into S by 6 pi to the power of half, which is obviously negative, isn't it? Because S by 6 pi is positive. Surface area cannot be negative, neither can pi be negative, and the square root of a positive number is a positive number. So therefore, this will be, and because I have a negative sign here, so this will be negative. So we say thus V has a point of local maxima at R is equal to 60 by or S by 6 pi to the power of half. S by 6 pi to the power of half has a local maxima. Okay. And what is it that you have to find out here? If you read this question, uh, show that this a closed circular cylinder of given total surface area and maximum volume is such that its height is equal to diameter of the base. That means you have to look for a relation between height and radius or the diameter. So if you want to look for a relation, then you can use one to find out the relation, right? So
Yes,
from,
sir.
so we have R is equal to S by 6 pi to the power of half. That means R square is equal to S by 6 pi. That means S is equal to 6 pi R square, right? So from 1, S is equal to 2 pi R into R plus H. Now put the value of, what is the, at what value are you getting the this maximum volume? At S is equal to 6 pi R square, right? So put it here, 6 pi R square is equal to 2 pi R square plus 2 pi RH. That means you get 6 pi R square minus 2 pi R square is equal to, this is 2 pi RH, is equal to 2 pi RH. That means 2 pi RH is equal to 4 pi R square. That means here, what is the relation between R and H? You take everything on one side. 2 pi RH minus 4 pi R square is equal to 0. Okay, so now you can take 2 pi R common to get H minus 2R is equal to 0. That means H minus 2R must be equal to 0. That means H is equal to 2R. This shows that when the volume of the cylinder is maximum possible,
When it is
height
equal
is
to
equal to,
diameter of circle of the cylinder.
diameter of the base. That's it. Okay.
Yes, sir.
Now we'll just understand the next problem and I'll solve it next week. Next week, as in Monday, you have a test. So not Monday. From Tuesday again, we'll resume our classes.
Okay, sir.
So let's just read the next problem and then so that you understand, and then we can call it off. Okay. Show that semi-vertical angle of the cone of maximum volume and of a given slant height is tan inverse root 2. Okay. Now, what do you mean by semi-vertical angle of a cone?
The top one, like that, the pointed one is called the vertical angle of the cone.
What about semi-vertical angle then?
Then the half of it is called the semi-vertical angle.
Then this angle is called the semi-vertical angle. Okay. If I call this angle say theta, then this angle is called the semi-vertical angle. You have to show in this problem that if this cone has maximum volume, okay, and if the slant height of the cone is given, that means L is given to you. That means L is a constant. L, this is the slant height. Okay, for a given slant height, that means L is constant. And if this volume of this cone is maximum, then you have to show that the slant height is theta is tan inverse of root 2. Okay, that is what you have to show. Fine. Now we can start this by saying that let h be the height and r be the radius of the cylinder. That means that you assume this to be h and radius of the cylinder to be r. Okay. So let h be the height and r be the base radius of the cylinder. So here r h and r are both constants. Okay, h and r are both constants here. Also, slant height equal to L, constant. Why constant? Because this of if you see of a given slant height, because of this phrase. Okay, slant height L is constant. So what is the relation between h, r and L? L square is equal to h square plus r square. That is the relation between h, r and L. We call this equation number 1. Okay, and now we you need to maximize the volume of the cone. So what is the volume of the cone? V is 1/3 pi r square h. Okay, but if we need to maximize the volume V has two variables, right? R and H. So we bring it down to a single variable with the help of this one. So from 1, you have R square is equal to L square minus H square. So putting this value in 2, let us call this 2. In 2, we get V is equal to 1/3 pi L square minus H square into H. Okay, that means V is equal to 1/3 pi L square H minus H cube. For maximum or minimum volume V, we have dVdH. Okay, let's first find out dVdH, then we'll say maximum minimum volume. Therefore, dVdH is equal to 1/3 pi L square minus 3h square for maximum or minimum volume. We have dVdH is equal to 0. That means 1/3 pi L square minus 3h square is equal to 0. That means L square minus 3h square is equal to 0. That means L square is equal to 3h square. Because h is a variable, we'll find h in terms of L. So h square is equal to L square by 3. That means h is equal to L by root 3. So at h is equal to L by root 3, volume is either maximum or minimum. Okay, so we'll use the second derivative test. d2v dh2 is equal to ddh of dvdh. ddh of 1/3 pi L square minus 3h square. So it will give you 1/3 pi is a constant. You can take it out of differentiation. L square is a constant, so differentiation of L square will be 0 minus 3 into h square is 2h.
2h.
Okay, so that is what you are getting here. So you're getting 1/3 of minus 6h, which is equal to minus 2h, which is equal to, now minus 2h you are getting here. That means now we need to check the sign at L is equal to L by h is equal to L by root 3. At h is equal to L by root 3, d2v dh2 is equal to minus twice L by root 3, which is obviously negative. Thus we can say that V has a point of local minima, maxima, has a point of local maxima at h is equal to L by root 3, right? Now we have got the value of h, right? Now we need to find this angle, right? Now if you see, angle is in terms of what? Tan. If it is in terms of tan, this, what is this tan? Tan theta is equal to r by h, right? R we have got, h we have got in terms of L. So from 1 we want to get r in terms of L. So from 1, L square is equal to h square plus r square. So L square is equal to L square by 3 plus r square. That means L square minus L square by 3 is equal to r square. That means 2L square by 3 is equal to r square. That means you get r is equal to L root 2 by root 3. Right? This is what you're going to get. The value of
Like
the
the
value
value
of
of
r. So therefore, tan theta is equal to r by h, right? Which is equal to, what is the value of r? L root 2 by root 3. And what is the value of h? L by root 3. So what you see here, root 3 will cancel, and L will cancel here. You simply get root 2. That means theta is equal to tan inverse root 2. So this shows that volume of the cone is maximum possible of given slant height when the semi-vertical angle theta is equal to tan inverse root 2. That's it.